We went to a school and noted the heights of a very large set of students. Let's make a line to denote their heights. The heights recorded were in meters. The heights recorded were between 0.9 and 2.1 meters. Let's mark heights with intervals of 0.2 meters, like 1.1, 1.3, 1.5 and so on. If we plot the number of students on this axis, then this is the data we get. Maximum at the 1.5 meters line. Equally distributed on both sides of 1.5, which is the central value. This point is the maximum. This type of distribution is called normal distribution, and the data is distributed equally on both sides of the central value. It is also referred to as the bell curve as its shape resembles a bell. But is the data always normally distributed? Does it always look symmetrical along the central value line? We look at an example to understand this. We wanted to look at the graph of income distribution per annum in a particular region. Say we have the incomes on this line. Let the income be in thousands of dollars. The range going from $10,000 to $100,000. Let's zoom in to look at the data closely. This is what we found. Majority of the people earn somewhere between $20,000 and $50,000. Very few earn less than $10,000 and very few earn more than $100,000. Here, the central value is around $50,000. Look at the figure closely. We can see a long tail on the right-hand side of the central value. Yes, it surely looks like a tail. But there's something important we need to know here. As the tail is on the positive side of the central value, we say that the distribution is positively skewed. It is not equally distributed on both sides of the central value. This is skewness. If we compare it to the normal distribution curve, we can clearly see the difference. Then what is negative skewness? To understand negative skewness, let's take a very simple example. We have the data of the marks scored by students in an easy test. Let the marks range from 20 to 80. We zoom in to understand the data we gathered. This time, the distribution looked something like this. This is the distribution of marks of students. Majority of the students scored between 50 and 80, while the central value is 50. We see a tail here as well. But this time, it lies on the left-hand side of the central value. Because it is skewed towards the left-hand side of the central value, we can say that the data is negatively skewed. Now let's zoom out to see all three distributions. In the normal distributions case, the data is distributed equally on both sides of the central value. In cases where the data is skewed, the distribution is not equal on both sides. If the tail is towards the right side of the central value, we say that it's positively skewed, and if it's towards the left, it's negatively skewed.